Welcome, everyone. I'm Galen George, the Director of Applied Science at Interscan. I'm excited to talk with all the sterilization professionals we have on today's webinar. Our focus today is on the current state of the healthcare sterilization industry and how recent regulatory changes, especially the EPA's rulings on ethylene oxide, are shaping our practices. I'll also discuss other critical sterilant chemicals like hydrogen peroxide and peracetic acid, and talk about gas detection technologies that we offer from Interscan. By the end, you should have a clearer picture of where our industry is headed and how advanced gas monitoring can enhance safety and compliance. Before we dive in, though, I just want to cover some brief housekeeping and introductions. So Susie Truitt, our distributor manager, is joining us today as our webinar moderator. Susie will be monitoring the chat and providing any relevant links for you. If at any point during this webinar you have a question regarding the content that I'm discussing, please make sure that you put that question in the Q&A function in Zoom and not the chat. At the end of the webinar, I will address the questions directly from that Q&A function only. So if there seems to be a technical issue, like if you can't hear me or the presentations, you can't see the presentation slides, then please make sure to put any of those concerns or questions into that chat so that Susie can address them. Okay, so now that the housekeeping is taken care of, let's move on to some brief introductions. So Interscan has been providing gas detection solutions to the safety, industrial hygiene, sanitation, and sterilization communities within a wide variety of industries, including healthcare, space, defense, manufacturing, and more, since 1975. In 2023, Interscan became a member of the CID Bioscience family of companies. We are headquartered in Camas, Washington, in the United States, where our team of engineers, scientists, assemblers, machinists, and technicians develop and manufacture all of our technologies and our product offerings. As I already mentioned, my name is Galen, and I am the Director of Applied Science here at Interscan. I've been in my current position for 6 years now, and my background is mostly in food quality and safety. So here's our roadmap for the next 45 minutes or so. We'll start with a high-level industry overview, setting the stage with how sterilization is done in healthcare today. Then I'll give a regulatory update focusing on what the EPA's new rules around ethylene oxide mean for us, especially in terms of required gas monitoring. We'll then discuss key sterilant chemicals, not just ethylene oxide, but also hydrogen peroxide and peracetic acid, which are increasingly used and have their own safety considerations. And then after that, we'll look at some fundamentals of different gas detection technologies. Then we'll specifically look at Interscan solutions, so you understand the tools available to meet safety and compliance needs. Finally, we'll leave time for a Q&A, about 10 to 15 minutes. So please jot down your questions or send them in as we go, and I encourage you to participate and make the session more interactive. So let's go ahead and begin. The healthcare sterilization industry is at an interesting juncture. We have multiple sterilization modalities, from traditional steam sterilizers for durable instruments to low temperature methods for delicate heat sensitive devices like endoscopes or plastic-based tools. Among these, ethylene oxide has been a workhorse because it can penetrate complex geometries and materials. In fact, about half of all critical medical devices are sterilized with ethylene oxide today. However, along with its benefits, ethylene oxide and other chemicals are under increased scrutiny. So we face challenges like ensuring worker safety and minimizing environmental emissions, all while maintaining the sterility and supply of medical products. Regulatory bodies like the EPA, OSHA, FDA, and state agencies are tightening standards. There's also a drive in the industry to find alternative sterilization technologies like vaporized hydrogen peroxide, gamma radiation, etc., but each comes with its own trade-offs. Overall, the current state can be summarized as highly effective but highly regulated, with professionals like us needing to balance safety, compliance, and efficacy in sterilization practices. So let's talk more about ethylene oxide. It's often considered the gold standard for sterilization of sensitive equipment. Its ability to penetrate packaging and device crevices is unmatched, and that's why things like catheters, stents, and electronics often rely on ethylene oxide sterilization. But this benefit comes with serious risks. Ethylene oxide is toxic, flammable, and a proven carcinogen. We as safety professionals know that chronic ethylene oxide exposure can increase cancer risk, especially blood cancers and breast cancer, and can cause reproductive hazards. OSHA has set a very low exposure limit, just 1 part per million as an 8-hour time-weighted average, with an action level at 0.5 parts per million to trigger remediation. There's also a 15-minute short-term exposure limit of 5 parts per million. These numbers are already low, yet, as we'll see later, new regulations are pushing expected safe levels even lower. In practice, facilities mitigate ethylene oxide risks through engineering controls, special ethylene oxide sterilizer units that capture and scrub exhaust, prolonged aeration of sterilized goods to let ethylene oxide dissipate, and PPE for workers like masks, gloves, and sometimes even full suits when unloading chambers. Despite all this, ethylene oxide has been in the spotlight because emissions from sterilization facilities have, in some cases, impacted surrounding communities. And you may have even seen in the news sterilization plants being temporarily shut down due to local air pollution concerns. So ethylene oxide's importance to healthcare is huge, but so is the imperative to handle it with extreme care. The EPA has responded to ethylene oxide risks with sweeping new regulations. So in March of 2024, they finalized a rule that compels nearly 90 commercial sterilization facilities nationwide to dramatically tighten their ethylene oxide emissions. This is a landmark change. EPA estimates these actions will reduce ethylene oxide emissions by over 90%, significantly lowering cancer risk for communities near these facilities. But how will this be achieved? So first, the rule expands what is regulated. It's not just the main sterilizer exhaust that needs control. Even building leaks or room air and chamber exhaust vents are now subject to these standards. Essentially, any pathway by which ethylene oxide could escape must be addressed. For example, using emission scrubbers or abaters on room ventilation systems and ensuring sterilizer doors and chambers don't vent ethylene oxide directly into rooms without treatment. Secondly, the EPA is requiring continuous emissions monitoring for most sterilizers. This is huge. So in the past, a facility might do periodic stack tests or rely on calculations, but now they'll need instruments constantly measuring ethylene oxide levels at emission points with data reported quarterly. This continuous monitoring and transparency means problems can be caught quickly and the public can be more confident that the air is safe. Another facet of this is the rule closes loopholes by demanding that emission controls apply even during startups, shutdowns, or malfunctions. No more uncontrolled venting just because a system is warming up or had a glitch. Backup measures must keep emissions in check 24/7. Facilities have a time frame, generally 2 years, extendable to 3 in some cases, to comply. And this extended timeline acknowledges the need to retrofit equipment carefully so that we don't inadvertently cause shortages of sterilized medical devices. So overall, these EPA rulings set a new bar for environmental safety in the industry. But the EPA's concern isn't just the air outside the facilities. It extends to the air that workers breathe inside sterilization units. In fact, earlier this year, the EPA signaled through a draft rule its pesticide re-registration process that they want to implement real-time ethylene oxide monitoring for workers as well. This is separate from, but complementary to, the emissions rule. The idea is that every sterilization facility would continuously monitor the ambient ethylene oxide in work areas and have alarms if levels get too high. But how high is too high? The number that's being floated is astonishingly low. It's just 10 parts per billion. To put that in perspective, the current allowable 8-hour time limit is 1 part per million, which is 1,000 parts per billion. And even the short-term exposure limit of 5,000 parts per billion. So we're talking about a threshold that's 100 times lower than the long-term exposure limit that has been historically used. This shows just how precautionary regulators have become with ethylene oxide. Basically, they want no one breathing even a whiff above background levels if it can be helped. So under the proposal, if a monitor detects more than 10 parts per billion, it would trigger mandatory PPE for workers. For example, staff might need to put on respirators and investigate the source of ethylene oxide immediately. It's a big change in practice, essentially treating any detectable amount as a reason to act. And for us, this means our gas detection technology needs to be incredibly sensitive and reliable. We're looking at near real-time, ultra-low-level detection instrumentation, something that Interscan has specialized in to meet these requirements. So while these workplace monitoring rules are in proposal stage and likely to be finalized soon, many facilities are already moving towards more aggressive monitoring in anticipation of this ruling. The rationale is clear. With ethylene oxide's cancer potency, the safest approach is as low as reasonably achievable exposure. And the technology has finally advanced to where continuous ppb level monitoring is feasible in the workplace. So now let's turn our attention quick to hydrogen peroxide as a sterilant. In recent years, hydrogen peroxide-based systems have surged in popularity. They're attractive because they're much faster. For instance, a VHP sterilization cycle might be 45 minutes versus several hours plus aeration time for ethylene oxide. Hydrogen peroxide is also appealing from an environmental standpoint. It doesn't produce toxic emissions in normal use. After it's done doing its job, it decomposes into water and oxygen. It's considered a greener sterilant in that sense, and the FDA just formally recognized vaporized hydrogen peroxide as an approved sterilization modality. Many of you will likely have experience with these systems like ASP's STERAD or Steris's vPro, which use H2O2 plasma or vapor. These are fantastic tools for quickly reprocessing critical instruments. However, hydrogen peroxide vapor is not without risk. It is a strong oxidizer, which is how it kills microbes, and it can harm humans at surprisingly low concentrations. The OSHA PEL is just 1 ppm as an 8-hour time-weighted average. If you recall, that's the same numeric limit as ethylene oxide's 1 ppm time-weighted average, although the ethylene oxide action level is lower. Exposures above 1 ppm of hydrogen peroxide can cause irritation of the eyes, nose, throat, and lungs. And higher acute levels might lead to coughing, shortness of breath, even pulmonary edema in extreme cases. It's not a carcinogen like ethylene oxide, but it's certainly hazardous. Think of it like a very strong respiratory irritant and oxidative stressor. In practice, are people actually exposed to hydrogen peroxide from sterilizers? Well, ideally, the sterilizer units are closed systems that convert most of that peroxide to water and oxygen at the cycle end. But in reality, studies, including ones by sterilizer manufacturers, have shown leaks happen. For instance, one study found that hydrogen peroxide vapor peaks at 13 to 60 parts per million inside a sterilizer chamber right after the cycle. And when the door was opened, that concentrated vapor whooshed out, exposing staff to levels far above the 1 ppm limit. Even small gasket leaks or incomplete pump down can let peroxide escape. Because these incidents are often not obvious, you can't always smell hydrogen peroxide until it's really concentrated and it's an invisible gas. The recommended best practice is continuous monitoring around these sterilizers. Detectors placed near the door or in the room can alert your staff if peroxide is present, allowing ventilation or delay in unloading until levels drop. So while hydrogen peroxide has clear advantages, it's important to maintain an eye on those vapor levels in order to reap all of the benefits of hydrogen peroxide safely. So let's now talk about peracetic acid, which is another chemical you might encounter in sterilization departments. Peracetic acid is commonly found in products for high-level disinfection. For instance, solutions like Steris's System 1 in the past or other automated endoscope reprocessors often use peracetic acid at around 0.2 to 0.35%. Peracetic acid is a potent biocide. It can kill bacteria, viruses, and spores rapidly. It's often used in combination with hydrogen peroxide or as a mixture. One convenient aspect is that it decomposes into acetic acid, which is just vinegar, and water, which leaves no harmful residue on the instruments. And because of that, it's considered an environmentally friendly choice for wastewater. Hospitals like that it won't create toxic runoff. In fact, the EPA lists it as a safer chemical for certain uses. However, peracetic acid vapors are very harsh. If you've worked with it, you know it has a strong, acrid odor like vinegar, but on steroids. It's actually more irritating than acetic acid alone. Acute exposure to even fractions of a ppm can cause immediate eye and throat irritation. People describe burning eyes, coughing, and skin irritation if they get a whiff of concentrated peracetic acid, and high concentrations can cause serious lung injury or pulmonary edema. The tricky part is there's no OSHA PEL specifically for peracetic acid. This lack of regulatory limit doesn't mean it's safe. It just means we rely on other guidelines. The American Conference of Governmental Industrial Hygienists has set a recommended short-term exposure limit at 0.4 parts per million. That's a very low threshold. So by comparison, common disinfectants like bleach have limits around a few parts per million. So peracetic acid in air needs to be kept at extremely low levels. In many hospital settings, peracetic acid is used in closed systems like endoscope reprocessors that should contain the fumes. But if those systems aren't sealed perfectly, or when you open them to retrieve instruments, peracetic acid vapors can escape. Because staff might not have a regulatory monitor requirement, peracetic acid sometimes flies under the radar. But incidents of respiratory irritation or even asthma in endoscope processing staff have been reported. The prudent approach is to monitor peracetic acid if it's used frequently. So ensure good room ventilation when using peracetic acid and consider fixed monitors in those areas to catch any buildup of vapors. It's all about being proactive, even in absence of an explicit OSHA rule, because we know peracetic acid can harm workers at very low concentrations. So by now it's clear that continuous gas monitoring is not just a nice to have, but a necessity in modern sterilization practice. These sterilant chemicals are essentially invisible enemies. Ethylene oxide is odorless at low levels. Hydrogen peroxide has no smell until it's irritantly high. And while peracetic acid has a vinegar smell, that odor threshold overlaps with harmful concentrations. We simply can't rely on smell or occasional badge tests to keep people safe. Continuous gas monitors act as our early warning system. They constantly sniff the air for any trace of these vapors and can alert us within seconds if something is amiss. From a regulatory standpoint, continuous monitoring is now being written into law for ethylene oxide emissions. As we discussed, the EPA will require ongoing monitoring and record keeping of ethylene oxide levels for sterilization facilities. This means if your facility uses ethylene oxide, you'll need approved detectors in places sending data to a logging system. Moreover, even without a specific OSHA rule for hydrogen peroxide or peracetic acid, the general duty to provide a safe workplace means you should be monitoring any significant chemical hazard. Inspectors or the Joint Commission for Hospitals will ask, how do you ensure staff aren't overexposed? Real-time gas readings with alarm logs are a very credible answer. Health-wise, the benefit is obvious. If a hose disconnects or a door is opened too early and gas starts leaking, a monitor will alarm immediately. We're talking potentially at 0.1 parts per million at those levels, or even lower, depending on the device. Staff can then intervene, turn on extra exhaust, step away, don respirators, and other protocols to add PPE or whatever they need to do to stay safe. And this can prevent an accident such as someone unknowingly breathing a high level of hydrogen peroxide and ending up in a clinic with burned airways, or a slow ethylene oxide leak going undetected and contributing to someone's cancer risk over years. By catching issues early, we convert what could be an emergency into a manageable incident. Another underrated aspect is process improvement. When you have continuous data, you can spot trends. Every time sterilizer number 2 finishes a cycle, we see a blip of hydrogen peroxide around the door. Maybe the seal needs to be replaced. Or we noticed a gradual rise in background ethylene oxide over the week. Perhaps an exhaust fan is underperforming. This insight lets you fix equipment proactively, which means less unplanned downtime and more consistent sterile processing operations. And finally, think about the peace of mind and trust. Employees who see that the facility invested in real-time monitors feel safer. They know the company is transparent and serious about their health. Some facilities even display readings on a board or at a nurse's station so everyone knows the current status. For example, ethylene oxide 0.000 ppm glowing green is a comforting sight. And if you ever have to communicate with concerned neighbors or regulators, being able to show hard data that we continuously monitor levels have been below thresholds for X months straight, that's extremely valuable. In summary, continuous monitoring is becoming the standard of care for managing sterilant gases, and it underpins both safety and compliance in our field. Now, before we dive into the specifics of Interscan's gas measurement systems, let's quickly touch on the technologies behind gas detection for sterilant gases. The good news is that the industry has developed sensors tailored for exactly these chemicals. The dominant technology we use for ethylene oxide, hydrogen peroxide, and peracetic acid detection is the electrochemical sensor. These are compact sensors where the target gas causes a chemical reaction, usually an oxidation reaction, at an electrode, and that produces an electrical signal that is proportional to the concentration of the gas. They are highly sensitive, so we can get them tuned to the low parts per billion, and they are very specific when we design them correctly. So, for example, an ethylene oxide electrochemical sensor won't usually respond to water vapor or other common gases. It's designed to react to ethylene oxide molecules specifically. Similarly, we have specialized peracetic acid sensors that exist that are essentially scrubbing out the interference from hydrogen peroxide so that they only react to peracetic acid. There are other detection methods that are maybe less popular. Photoionization detectors can pick up some organic vapors, but they're not very selective, and they're more often used for solvents rather than oxidizers like peracetic acid. Also, hydrogen peroxide doesn't ionize well in a photoionization detector. We also have infrared sensors. They're great for some gases like CO2 and hydrocarbons, but for ethylene oxide or hydrogen peroxide, infrared can be problematic because these gases absorb weakly and moisture can interfere with the readings. In fact, one advantage of electrochemical sensors is that they often handle humidity better, and some systems specifically note that they're not affected by moisture in the air, unlike infrared. So the state-of-the-art sterilant gas monitors you'll encounter are mostly going to be electrochemical cell-based. Now, in terms of deployment, we have fixed monitors and portable monitors. Fixed monitors, like wall-mounted units or a sensor box on or above a sterilizer, are meant for continuous surveillance. They usually have an audible alarm and a flashing light to get your attention. These might be networked together, all feeding back to a central panel or a computer display. And then on the other hand, you have portable monitors, which are usually battery-powered devices that EHS staff or technicians can carry around. Like suppose if you smell something odd or you want to do a routine check around the equipment, you'd use a portable to sniff around doors, seals, and tubing connections, storage areas, etc. And so portables are also used for personal monitoring, where a worker might wear it during a task, like changing an ethylene oxide cartridge to ensure that they're not being exposed. Many hospitals will use a combination, fixed units for round-the-clock safety and a couple of portables for ad hoc investigations and double checking. When evaluating detection systems, I think these are the key features that you need to consider. Sensitivity is paramount. We want detection thresholds well below the danger limits. For instance, if the limit is 1 part per million, a good monitor should detect 0.1 part per million or less. We saw EPA may ask for a 0.01 ppm detection limit for ethylene oxide. So that's a target in any new gear that you acquire. Specificity also matters because we don't want false alarms every time someone uses bleach or another unrelated chemical. Manufacturers like Interscan will add filters or chemical scrubbing to their sensors to mitigate that cross sensitivity. The response time is also very important. Ideally, you want the response time to be in seconds. If a leak occurs, we don't want a monitor that takes 5 minutes to respond. For reliability and maintenance, you want to make sure that the device holds calibration. You need to know how often you have to swap out your sensors or recalibrate. And then companies like Interscan may offer you guys services to send pre-calibrated replacement sensors periodically to keep things plug and play, to keep the onus of calibration off of the end user. And data logging has become a standard ask. It's great if the monitor records values so you can print a report for your OSHA log or for an inquiry or look at trends over time via graphs. So those are all important factors to consider. And then finally, the last thing to think about is how will this system integrate in your facility? So many modern monitors have digital outputs or even sometimes Wi-Fi or Bluetooth. If you have multiple monitors, you might have a central console or controller or a software that collects all the readings. These integrations allow remote alerts like emailing or texting a safety officer if a leak is detected at 2 a.m. And ensure that all stakeholders have visibility. So having framed that generic test aspect of these systems, let's look at what Interscan can offer in terms of gas detection in these sterilization settings. So as I mentioned before, Interscan has been in the gas detection business for decades, since the 70s. And we've developed a variety of instruments. One of our biggest strengths is the breadth of gases that we can detect. Not only do we cover ethylene oxide, hydrogen peroxide, and peracetic acid, but also other gases like formaldehyde, which is used in some legacy sterilizers or labs, ozone, which is a newer sterilizer that some people use, or ozone peroxide mixes, nitrogen dioxide, and then many, many other gas types. So that means if your facility has multiple sterilization modalities, you can get all of your monitors from one place and have a consistent interface and support structure. The density and precision are also hallmarks of Interscan devices. We know the regulations demand detection in the low parts per billion for ethylene oxide, so we have sensor options that cover that. We have ethylene oxide analyzer options that measure 0 to 2,000 parts per billion with fine resolutions, with 1 ppb resolution. This kind of range is ideal for monitoring well below that 1 ppm OSHA limit that is currently in place and is in line with the EPA's new 0.01 ppm threshold proposals. So similarly for hydrogen peroxide and peracetic acids, our devices can detect fractions of a ppm reliably. We use active sampling, so that means our fixed monitors have an internal pump that draws an air sample over the sensor, which is great because you can pull air from a specific point, like just above the sterilizer door or from an exhaust duct, right into the monitor, which then can be mounted in a more conveniently placed location. So you can have it on a wall, and that is more accessible, and have sample tubing that directs right to that specific sample point. And then that active sampling also ensures a representative sample and often gives us faster response times than waiting for a gas to diffusively wander into a sensor, which is what some other electrochemical sensor technologies will rely on. Our fixed monitoring systems like the AccuSafe and the AccuSafe Solo systems will give continuous readouts. They can be configured with different alarm set points. For example, an alarm at 1 ppm as an 8-hour time-weighted average, 5 ppm as a 15-minute time-weighted average, and 10 ppm as a ceiling alarm, or whatever your safety policy dictates. So all of those alarms can be done simultaneously, and you can get alerts for all of those different alarm levels. These monitors are built for healthcare environments, meaning they're calibrated and tested at these extremely low levels of sterilant gases, and they are stable. They provide early warnings, so if ethylene oxide or hydrogen peroxide start creeping up, you'll know right away on the display and via alarms. We emphasize reliability. For instance, our design often includes active sampling with filters to avoid cross interference and to protect the sensor from excessive moisture or dust. As mentioned in literature that we provide, we pride ourselves on high sensitivity and accuracy to meet the strict standards in hospitals. Maintenance is an area that we have innovated in with our interchange sensor cartridge system and our Sensor Express subscription service. So one pain point with gas detectors can be the sensor calibration and replacement. Electrochemical sensors typically last 1 to 2 years before they need replacing. Rather than leaving customers to handle that alone, our Sensor Express program will automatically send you a calibrated replacement sensor at whatever interval is appropriate. So say it's every 6 months, you would just simply pop out the old sensor module, put in the new one, and you're essentially immediately back to full accuracy without having to do any manual calibration with test gas on site. The old sensor can be sent back to us or can be tossed. And this subscription approach means that your system never lapses in protection due to like a spent sensor or a missed calibration. It's a really big plus in healthcare specifically, where you have a million other things that you've got going on that you have to manage. So this just makes it one less thing to have to worry about. As far as data logging and integration are concerned, the AccuSafe system supports standard Modbus protocol in both RTU and TCP IP mode. 4 to 20 milliamp analog communication to visual or audio alarms is made possible via a DAT-XL converter that we offer. And so with both digital and analog communications available, you can tie them to a building management system or an alarm dialer, or pair it with external data loggers. With the AccuSafe system tied into your local network, you can easily access and download all of the data logged by the system from a PC. And with that level of flexibility, you can easily capture the exposure data. For example, if you want a monthly report of ethylene oxide levels in your department, that can be done. Or if you want the monitor to trigger the building's ventilation system to kick on an extra exhaust fan when ethylene oxide is detected, that's doable through our outputs on our device. So in short, Interscan's goal is to provide a comprehensive, easy to maintain monitoring solution that fits seamlessly into your safety protocols, so that you can focus on running the sterilization operations with confidence that the atmosphere is being constantly watched. So as we wrap up, remember that the world of healthcare sterilization is changing, largely for the better. We're seeing a greater emphasis on safety and accountability. And yes, that means more work in the short term to upgrade systems and train staff, but it yields a safer workplace and community. Ethylene oxide in particular is under the microscope. The EPA's actions underscore that we can't do business as usual with ethylene oxide. By law, we'll need to install better emission controls and monitoring. Think of this not just as regulatory checkbox, but as doing the right thing for our colleagues and neighbors. We've also highlighted hydrogen peroxide and peracetic acid. These are gaining traction as alternatives, but we must handle them with respect too. They're not benign, and incidents can happen if we're complacent. The good news is we have ever-improving technology and solutions to meet these challenges. Gas detection systems from Interscan are extremely effective guardians. They run 24/7. They don't get tired, and they don't get distracted, which is exactly what you need for vigilance. If you haven't already, I highly encourage you to evaluate your facility. Are you adequately monitoring for these sterilant gases? If not, it's time to plan for it. It might even be required soon under regulations, but even if it weren't, it's a best practice. Ultimately, our goal is to sterilize instruments without harming anyone in the process. With careful attention to engineering controls, administrative policies, and continuous monitoring, we can achieve that goal. Patients get safe devices, workers go home healthy, and communities breathe easier, literally and figuratively. So thank you for your attention. I'm going to move into the Q&A portion now. I likely might not have time to answer every question, but for any questions that I'm not able to address, I will happily receive those from you via email, call, or video consultation. I appreciate your participation and the work you do in keeping our healthcare safe. And if you want to get in touch with us, feel free to contact us via email, via phone. You can visit our website at gasdetection.com. You can also always stop by for a visit if you're in the area. You can also email me directly. Susie has posted my email in the chat. If you do have questions, you can just reach out directly. And if you are interested in pricing in any way for our Gas D8000, which is our portable device, or our AccuSafe system, feel free to click the link that Susie has posted in the chat to request a quote from us. And that'll put you in touch with me, and we can make sure that we quote you for a system that suits your facility's needs exactly. So thank you everyone again. And I'm going to go ahead and pull up the Q&A function here and see what kind of questions we have. The first question is from Kelsey. For continuous monitoring, does that data need to be stored, or can it be continuous monitoring with no data storage and just periodic, i.e. daily, etc., noting of the ppm levels? So you are going to need to have that data logged and stored. So in order to report your levels, you will have to have a log of the data stored that you can actually go back to. So I just, simply writing down the level of ethylene oxide on a sheet is not going to cut it anymore. So the next question I see is, how do facilities test emission levels of ethylene oxide? So the emission levels aspect of this is definitely a little bit more difficult. The standard is going to be whatever technology is capable of measuring those levels and also being able to accurately sample from the emissions points. So in this case, there's a really good, strong use case for electrochemical sensors. Currently, emission levels testing, as I mentioned, is not really something that is a continuously monitored thing. Typically is up to either outside regulatory bodies or the facilities themselves to do random spot checks of their emissions. It's not something that's been closely monitored, which is why this new regulation has come out. And then the follow up to that is, can we send you a hyperlink to the new guidelines, the new FIFRA or FIFRA ruling there? And yes, we can. Well, actually, if you want to just get in touch with me, I can send you the link. I don't know if Susie is going to be able to find it and pull it up here in time, but what we'll do is we'll have her maybe send it out with our follow up to this webinar. We can maybe send that link out. Let me look at let's answer a couple more questions here, and then for all the other ones, I'll respond via email. So let me see here. For ethylene oxide sensors, what is your lower detection limit of your electrochemical sensors? So that's a great question. We have a 1 ppb detection limit for our portable units. And for our AccuSafe sensor system, I believe it's somewhere between 1 and 4 parts per billion as our lower detection limit. And then also for the ethylene oxide sensors, what is the response time for your electrochemical sensors? That's a great question. So response time, our T90 is typically under 1 minute. I believe it is, I'd have to look up the exact number, but I can get back to you on that. But I know that it's less than a minute for our AccuSafe sensors. For our Gas T8000, it would be even less than the AccuSafe. So should be totally sufficient for catching leaks quite rapidly. Will ethylene oxide OSHA standards change along with the EPA? That's a great question, George. With all this regulatory landscape that we exist in right now, I think that, there's to me a 50-50 chance that we see the OSHA standards change at the exact same time as this EPA ruling gets finalized. I'm sure that'll be a slow rollover, but I would hope that in time OSHA would adopt those same standards that the EPA is issuing. And so for the other questions that we have left, I will ask that I'm just going to go ahead and say here, I'll answer those over email. If you want to reach out to me, send me those questions directly, or I can hopefully from your attendance list, I can pull up your emails and send you an email to respond to your questions. But yes, thank you all for participating today. Again, if you have any further questions, email me directly, email sales@gasdetection.com. If you have interest in pricing, you can go to our website and see all of our offerings. You can always give us a phone call as well. And we are happy to talk to you about how to get you compliant with these new regulations and make sure that you are operating a safe work environment for all of your staff. So thank you again for your attendance, and we hope to see you again soon.